Okay, again, we want to eliminate the parameter t and then graph the resulting equation. And this time we have x equal 3 plus 2 secant t, and y is equal to 2 plus 4 times tangent t. So we're going to need one of our Pythagorean identities again that relate tangent and secant to each other, and it's this one. 1 plus tangent squared is equal to secant squared. So we have to know this right here in order to eliminate the parameter t. So I'm going to solve this equation right here for secant t. When I do that, I'll get 2 secant t is equal to x minus 3 when I subtract 3 from both sides. Then I want just secant t, so I'm going to divide both sides by 2, and I'll get secant t is equal to x minus 3 all divided by 2. Now likewise, I'm going to do the same thing here for tangent. I'll just do it all at once. Tangent t is going to be equal to y minus 2 all divided by 4. So here's my expression for secant t. Here's the expression for tangent t. I'm going to take these two expressions and substitute them in here. So I'll take these two expressions, substitute them into this, and I'll end up with 1 plus tangent t, which is y minus 2 over 4, y minus 2 squared over 4 squared, which is 16, is equal to secant squared t. So secant t is equal to this. So secant squared is x minus 3 squared, all divided by 2 squared, which is 4. So I kind of did two steps at once because secant t is this, so it's this quantity squared right here, which is the numerator squared divided by the denominator squared. So x minus 3 squared divided by 4. Now let's rewrite this in a little different form. I'll take this right here, leave it where it is. I'll subtract this expression from both sides, and I'll have my equation. So when I'm done, it'll be x minus 3 squared divided by 4 minus y minus 2 squared divided by 16 is equal to 1. So I can tell when I look at this, now I have the equation of a hyperbola. So the center is going to be at x equal 3, y equal 2. So let's look at that. 1, 2, 3, 1, 2. And then I can make my little box where I get my asymptotes by looking at the square root of the number below the x term and the square root of the number below the y term. So below the x term is 4, the square root of that is 2, so I'm going to go 2 units in that direction, and then 2 units in that direction. And then what's below the y term is 16, so I'm going to go 4 units up, so 1, 2, 3, 4, and then 1, 2, 3, 4 units down. That gives me this little reference rectangle. And then I know my asymptotes are going to be these lines right here. And so let's see, how am I going to draw my hyperbola right here? Well, let's see, I can have values of x. Let's see, it's going to come out right here and right here, and it's going to go up and then back down like this, and then down and down like that. Now the question is, what are the x-intercepts and what are the y-intercepts? Well, to find that, I have to let y be equal to 0 to find the x-intercepts, and then x equals 0 to find the y-intercepts. When I do that, I find out that y is equal to negative 2.5 and 6.5, so I'm a little bit off right here. And then 1, 2, 3, 4, 5, 6.5 up there. And the x-intercepts turned out to be 0.8. That's about right. And 5.2. 1, 2, 3, 4, 5.2 is about there. In any case, you can do that. That algebra or arithmetic is a little complicated. You can go to a graphing program like Desmos, and it will give you the graph and show you what the intercepts are. In any case, this is going to be a hyperbola, and I find it by using this Pythagorean identity that relates the secant and the tangent. Okay, and then you can check your algebra right here, see that this is exactly the equation of a hyperbola, center at 3, 2, and then these numbers allow us to draw the little reference rectangle in there, and then I can see what the asymptotes are. So anyways, another problem where we eliminate the parameter t from a set of parametric equations.